This is how to find the distance to the horizon from any altitude. It's really easy. It's just Pythagorean theorem. I have a diagram of the Earth right here. We have radius from the center of the Earth to the circumference. And then somebody will be at a certain altitude right here. So we'll have radius plus that altitude. The people in this airplane or tall building or spaceship or whatever, when they look straight across this straight line right here that forms a tangent line to the circle, right where this tangent line touches the circle, that is their horizon, and they cannot see anything beyond that. So it's a squared plus b squared equals c squared, which is radius squared plus b squared will equal the quantity of radius plus altitude, quantity squared, right there. This will give you an accuracy up to 99.9%, all the way up to 8 miles high from a commercial airliner. If you go all the way up to the International Space Station, which is 250 miles high, at least according to Google, that will give you a 96% accuracy. So that's it. That's how you do it. Easy Pythagorean theorem. But keep watching if you want more details, and I'll give those now. If you want even more precision, then you can use the formula cos theta equals radius over radius plus altitude. That means you can take the arc cos of radius over the quantity, radius plus altitude, to get theta. That'll give you an angle of theta. Theta over 360 degrees equals the distance over the circumference. And that's the distance along the surface of the Earth right there. This makes sense because if your angle is, say, 25% of the whole circle, so that would be 90 degrees, then that means the distance right here, that arc length, will be 25% of the whole circumference. I had used D for distance instead of A for arc length because I already used A here for altitude. The reason Pythagorean theorem is so accurate is because I drew a representative triangle right here to the right. And you can see that in reality, these angles are so narrow that the hypotenuse is almost identical to the adjacent, which means this segment B right here is in Bravo, sits right over the surface of the Earth, unless you're just way out into space. So basically this little segment right here at the top, that is line B for a somewhat scale model there. So that's it. That's all there is to it. If you just want to use elementary school math, you can do a squared plus b squared equals c squared. And if you want to get fancy and do a little trig, then you can use the arc cos.